Okay, thanks for inviting me to this lovely city of yours. It's been interesting to explore, and thanks you guys for coming. So I'm the lead of the Eclipse modeling project, which started quite a few years ago as sort of the Eclipse modeling framework and the graphical modeling framework. I've been working on this stuff for 10 years. About 8 of those years were at IBM, and now I'm independent. I do a lot of consulting for Itemis. They're my primary funder, and they make a lot of this open source stuff possible. So this talk is about Xcore. It's bringing Ecore, a language for defining abstract syntax, together with Xtext, which is a language for defining concrete syntax. So we're bringing those two things together, basically endowing Ecore with the textual syntax. So it's a well-established fact that EMF is great. It's used in hundreds of products at IBM. It was used in I think Mike said 500 products at IBM. I think most of those make use of EMF. It's broadly used across the Eclipse ecosystem. If you think of what Eclipse is about, the platform itself was focused on integration of user interfaces. So you could bring together various parts of a user interface and create a cohesive whole. What EMF is about is sort of a second pillar in that integration. It's bringing the data itself together so that you have a uniform way of representing the data. No matter where the data is coming from, you can reflect on it, serialize it, work with it in a very sort of high-level abstract way and bring all that data together. So that's kind of been its focus, and it's been extremely successful at doing that. It's been described as Java beans on steroids. So it's essentially like a bean model. You have objects with properties, and you have getters and setters for modifying those objects. But the on steroids part is this high-level reflection. It's not just Java reflection where you see the implementations, but rather a high level where you know what features and what their multiplicities are, and you have things like bidirectional relationships, sort of parent and child, that are intrinsically related and need to be kept integral. So it supports all those kind of things, even a whole notification system, so you can add adapters to your objects and listen to them changing and keep a UI in sync with those changes. This notion of containment is fundamentally important. If something like Java beans is basically like spaghetti, the objects all reference each other. With something like EMF, there's a strict hierarchical containment system similar to DOM. So if you have an object that can contain other objects, if you delete that object, everything it contains is deleted as well. So that's a very fundamentally important concept. We have a resource framework on top of all this, a notification framework like I mentioned earlier, which isn't just for UIs. You can imagine sending your objects to a client, they make a bunch of changes, you listen to what those changes are and create a description of the delta and send that back to the server. So you could have massive objects that are being sent to the client, but you're only sending very small deltas back to the server. And we have this resource framework. So you can think of it as very similar to on a web browser, you have tabs, and those tabs have HTML pages. EMF has a similar idea that there are resources that are identifiable by a URL or a URI, and all the objects, all your data is contained in a hierarchical way, much like HTML and those resources, and they can have cross-links between them. It's a very powerful system that's essentially like REST-based. It's what's the basis for the web itself. And there's a bunch of other cool stuff. So it's like a layer of onions with EMF at the core, and then there's a bunch of projects built around it, things like CDO that you'll see later, very interesting things like Xtext that you'll see as well. It's a very diverse ecosystem. But it's not one big happy party. There are some downsides. And the biggest one is the tools themselves. No one has invested heavily in making the tools super sexy and super usable. They're adequate for the job, but they're really not excellent tools. Another problem is merging. We generate code, so you have a high-level description of your model. We generate code from that, but you end up having to write some logic behavior for operations and stuff by hand. So you end up sort of making changes to generated code and some of the associated problems with that. And also a turnaround. So you have a generator and you're focused on modeling, and then you're going to code, and the context switching between them kind of slows the process down. So that's where Xcore comes into the picture. It's a textual syntax for Ecore. So basically trying to create a simple programming language out of something that right now you'd use a structured editor or a graphical UML-like editor to do. It's a very cool editor. It's generated with Xtext, which is amazing technology. You write a grammar for your language, and you immediately have an editor with syntax highlighting, completion, all the kind of things that you see in JDT that you're sort of comfortable, familiar with, and have grown to love. One of the designs here is that we generate the code on save. So as you're editing an Xcore file, when you save it, the generated code is produced. Much like in JDT, when you save a Java file, all the .class files are produced, and you stop thinking about needing to run a compiler. It happens under the covers. And there's no generator model anymore. So we have sort of the Ecore model that describes your structure, and then we have this decorator model that describes how to map that description onto Java. Those are two separate artifacts. With Xcore, we bring those into a single file. So these artifacts are still there, but they're derived and under the covers. And most important of all, we have a way of specifying behavior now. The Xtext project provides a language called Xbase. That's sort of a reusable expression-oriented language with sort of the full repertoire of what you'd expect from Java, generics, all the control statements, and so on. And it's highly reusable, and we reuse that in Xcore to define behavior. So you can not only define the signature of an operation, but also the logic for what it actually does. So let's have a look. Enough of the slides. We'll show this stuff in action. So we'll bring up an empty instance of Eclipse, and we'll start by creating a new project. File, new project. And we have a special wizard. The project wizard has nice filtering, so if you type Xcore, it filters it down to the wizard I want to use. And we create a new project. So I'm going to do a very simple model here. We really don't have a lot of time in the schedule to do a more interesting, a little more clearly. That's part of the problem. Every time I lean down, then I'll be too close to the mic and then farther away. So I don't have enough time to do a nice, more complex model. What I'm going to do is sort of a first year data structure, build a tree structure. So a tree with nodes and children, and show how you'd specify something like that in Xcore. So we'll name the project org example tree, and accept all the rest of the defaults. So it creates a simple project. This project is a Java project. It's also a plugin project. So basically a normal project. It's also got the Xtext nature on it. So you see the little X decoration. So that helps it participate in the Xtext Frameworks Builder integration. But really it's just an empty Java plugin project. The only thing that's special about it is some of the dependency initializations. So the project depends on Ecore, and it depends on the Xbase libraries, which are needed for compiling the logic for specifying behavior. So that's really all that's special about it. So next we'll create our first Xcore file. I don't have a fancy wizard for it yet, so we just create a file with the right name. We'll call it tree.xcore. And it creates the empty file. But it brings up the generated editor for Xcore. So you can see the file starts out with an error. An empty file is not a valid file. So we can start making it valid. So what I just did is hit Control Space. So it knows an Xcore file has to start with the package declaration. It's the only thing you can put at the beginning, so it completed that. And then we give the package a name, org example tree. So exactly like you do in Java. And then we want to define a class called node. to represent sort of the basic part of our tree structure. So again, it's very much like the JDT. When I typed in the leading curly brace, it put in the closing curly brace. If I want to add additional things and I hit Control Space, it shows me what keywords are available for defining the top level entities in this file. So very familiar. It gives you the feeling like you're in JDT. So we'll give nodes a label, and we'll make that label be of type string. So we'll start typing, hit Control Space, and it knows string is an appropriate data type, one of the few that are visible at this point. And we'll call that the label. And now we'll save. So you see, looking at this, it looks exactly like Java. So that's on purpose so that you have a familiar syntax and a familiar notation. But if you look at some of the subtleties here and you look at the hover help, this is actually a use of EMF's eString data type. So we've created aliases with identical names to the Java built-in types, but they are aliases for EMF data types. So once we create something like this, we can already start creating dynamic instances of it to test whether this model is behaving in the way that we want. So we would do that by clicking on the class and say create dynamic instance. We don't really care the name of the file, we'll settle for the default. So we're creating a file that has a single node in it. And if you look at the properties view, it's got a label feature. So I can call this node root, and the label updates in the tree view. So this is a fully dynamic model. That's one of the aspects of EMF, is when you define a model, you can emulate the behavior of what you've defined dynamically, or you can generate Java code that produces the behavior that you've defined. And these, whether it's dynamic or generated, the rest of the frameworks built around EMF don't care because they use reflection to work with the instances, not the generated Java APIs. So that's a relatively uninteresting model so far. We want to make it a little more exciting. So it is a tree structure, so tree nodes have children. So that's the next thing we'll define. And here's the first difference you'll see with Java, that we have a special keywords for defining what type of reference this is. So things can be a containment reference, which create the downward pointing hierarchy. Things can be a container reference, which are the reverse pointers up the hierarchy, or we can have cross references, which hopefully I'll have time to show you later. But in this case, it's a contains relationship. We can hit Control Space to see what other E-classes can we refer to. There's just node in scope at this point, and we want this to be multi-valued. So one way of doing that is to specify the multiplicity in the sort of UML notation, but as a convenience, we make the empty square brackets mean sort of 0 or more instances. So we can have a node with children. So that's basically it. And again, if you look at this, this looks like a Java array notation. It's just got the keyword saying this is a containment versus some other type of reference. Once we do this, we can go back to our dynamic instances and make use of that information. So we can say create a new child node now. And of course there can be multiple children, and we can set the labels on those children. All the kinds of things that you'd expect are supported. Let me make that unique. Can support things like drag and drop to move things around. So all of this behavior I'm showing in this dynamic editor, that's also the default behavior you'll get in EMF's generated editor. But that behavior, once you generate code, you can go and tailor and specialize. So let's go back to the model and define the opposite of the children relationship, a container relationship, which will also be of type node, and we'll call that one parent. Now, a container relationship has to have an opposite. It has to be the opposite of a containment relationship. And you specify that by using the opposite keyword, and then you have to type the name of a feature that's within scope there. In this case, it'll look at the type of the container reference. It will expect to have a feature of the right type to point back at this object. So that's really only the children relationship. So when I complete that, you'll see the opposites are inserted in both directions. So if you have a node and ask it who's your parents, you're going to get another node back. If you ask that node who are your children, you're going to find yourself among those children. And those two things are maintained consistently. So I'll show that in the generated editor. Now that I have that defined, we can look at the node B and see it's got a parent relationship, and that parent is set to A as you'd expect. And we can go and edit that parent relationship. One of the things, when you click on this relationship, you'll see the editor gets quite busy and quiet. What it's doing at this point is it's walking everything in the entire resource set to find all of the objects that conform to this relationship. And that means that all of the Java reflection of all of the models, all of the Java things that these models depend on all get pulled into memory. So you can see it did a lot of work here to pull in all kinds of Java code. Plus my machine, I unfortunately didn't bring my charger, and I'm using Ike Stepper's charger, and my machine complains and says that's not enough watts and I'm going to run very slowly for you. So that took extremely long. So that's why I thought I'd explain why it took so long. So if we look now, it's populated, doesn't have to do all the work to build that relationship, and I can say I want the parent of B to be the root node instead, and you see it moves in the tree depending on that. So that's one of the powerful things about bidirectional relationships, is you can edit either end and the model automatically keep those up to date. And I've got a longer talk that I do where I show the mechanics of actually how that's maintained, and it's extremely complex. When you set a bidirectional reference, there can be as many as 6 references that need to be updated, removing them from where he is, making sure that that back pointer points at the new one, and it's a very complex process. And in one of the trainings I do, I get people to implement this by hand, and I've yet to see anyone implement that bidirectional reference handshaking properly by hand during one of these sessions. And EMF enforces that. You can't get these things wrong, and they're very easy to get wrong. Okay, so what I've shown so far is just stuff that you could do with Ecore. So this is a nice textual notation for that, but there's nothing more powerful than you could do before. Let me show something else you can do. What we can do is define an enum called node kind. And we'll describe the relationship of sort of a node status in the tree. You can imagine it being the only node in the tree, it being a root node, intermediate node, or leaf node. And you might want to define a feature that represents the node's role in the tree. So you could do that with a derived feature called node kind. Another nice thing we have is even variable name completion is there, much like in Java. From the type, it decides what's a good feature name. Now here we can define the getter method that computes this feature from the other values in the system. So in this case, we can check if the parent, and again, all the nice completion things are there, so I put in P, and parent is the only variable that's in scope here. If the parent is null, then if the children are empty, so if there's no parent and there's no children, then I must be a singleton. So let me do node kind. Let me make this this big so that there's room. So if there is no parent and there are children, then we must be a root node. And then let me be lazy and save typing and copy. Oops. One of the problems I always have is at home I use a ThinkPad plug-in keyboard, and the function key and the control key are in exactly the reverse position, so I'm never sure whether I'm hitting a function key or a control key. So in the other case, when there is a parent and there are no children, then we must be a leaf. And that only leaves the one case of intermediate. So that's the logic. Now we have a feature that describes the node sort of role in the tree, all defined within our model. I keep closing the generated editor because it's actually not smart enough to see the underlying model has changed. I need to reopen it so it reads the model again. So now if we look at this tree structure we have, you can see the derived relationship that's a root node. This is a leaf node. If we move the guy under there, you can see it's an intermediate node. So we can verify that the logic we're building is working correctly even without generating code and without launching a runtime Eclipse instance. I don't have a lot of time in my schedule, so I'm going to skip some of the things I usually show. It's very easy to define a data type as well. Oops. We would do that by defining a type. We might call it label. That wraps some existing Java types. We might want to reuse EMF's URI class. So one of the things you could do here is to define the methods for creating an instance. So we check if it is not equal to null, then do URI, create URI of it. So in this case, it is a little bit like the this pointer. It's the implicit literal value of this thing. So it's a string value. If we hover over it, you can see that it's of type string. And we can do similar for the convert function. There we get it is an instance of the URI itself. So the converts. Oops. And we can use a convenient notation from Xbase and convert it to string. So this is basically a null-guarded pointer use. So if it's null, the value returns null. Otherwise, it calls the toString method. So that's how we can convert between a value from a literal value to an instance of a URI, and from that URI back to a literal value. I want to quickly show that there is a bunch of generated code things going on under the covers. I haven't shown it at all, but in the source.gen folder, you can see all the generated code. There are things, accessors for the label. If we go into the Xcore model, comment something out, you can see the label, the getters and setters for the label. Everything to do with the label is removed from the generator, from the generated code. If we put that thing back and save it, you can see that those features show up again. So much like in JDT, that you generate class files but you don't think about them, the same thing is going on under the covers here. You get generated code, but you don't need to sort of monitor and maintain that. That's all maintained automatically for you. If you're familiar with EMF, you know that it generates things like item providers and an editor as well. So the way we can make the Xcore do that is if you select things and you look at the properties view, we have the same properties view we have in our GenModel editor, in our generator. So I could find the property for the edit package where it says what's your edit directory, And I can say org example tree edit. I want it to go in the source folder. And you'll see it generates an annotation, much like Java annotations. So there are a few built-in names like @GenModel for defining all these generator-based annotations. And if I save, extend working, it creates the item providers in the edit project. So all of the stuff that was familiar and available with EMF, with the older technology, is all at your fingertips with Xcore. I didn't have time to show sort of writing an operation, but it's a very simple to write sort of op and exactly what you'd be familiar with writing a Java method. And of course, this stuff works with models that extend other models. And one of the things I was working on last week with the guys in Kiel is refactoring. So what we're hoping by this release is when you refactor something in your Xcore model, that all of the downstream Java code you've written by hand or that your clients of your models have written by hand will also automatically be refactored to reflect those changes. So there's a lot of powerful features here, but my time is very close to being up and we want to keep on schedule today. So I'll close with that. Let me put up a slide with some information if you want to find out more. And then I'll take one or two questions, if there are any. Yes?
Could you say something about the expressive power of the part?
So he's asking about how expressive the behavioral model is.
Exactly, and what the roadmap is, and also extensibility that you may have planned.
It's using Xbase. It's completely reusing Xbase. Everything that you can do in Java, you can do with Xbase. It's generally a more concise syntax. So things like the parentheses for calling a method when there's no arguments is not needed. It's also more powerful in that you saw I said children.empty. That is actually calling the isEmpty method, but it knows these patterns of is something and get X and get Y, and it will make it look like in the case of the getters, you can just refer to X or Y instead of get X and get Y. So it's extremely expressive and very powerful, and it is extensible. So Xtext or Xbase is a grammar that you can refine and add additional constructs to. So one of the things I still want to look at is with EMF, you always have to go to a factory and tell the factory to create the instance. It would be nice to have a convenient notation that says just create an instance of this E class, and that under the covers it knows where to find the factory and do all that.
Could I or would I want to include OCL support in there?
The OCL project does have something equivalent to this. They've defined this sort of complete OCL, and they've got an emphatic-like syntax very similar to this. And then they can define constraints and stuff in OCL. Xtext doesn't let you interchange sort of embedded grammars. That's a very hard problem. The lexing of a syntax, you really have to know the full syntax. So making it sort of pluggable that we could put in OCL or Xbase is beyond what we can do with Xtext at this point. It would be a great feature, but beyond what we can do. Okay, that's probably good. We can stay on schedule. Thank you very much.